Hello everyone. Today we're looking at how to write piecewise functions given some form of graph. So questions 1 and questions 2, we are given a graph to work with, and from that graph we want to write the piecewise function. Now, you may have heard of the KISS rule. Keep it simple, silly. For this first problem, we've got a line, another line. While it might be tempting to try to make one of these into an absolute value function, we should, and we definitely should, keep this simply as 3 linear functions. So if you may recall, back from Algebra 1, a linear function has the equation of y is equal to mx plus b, where the m is essentially going to be your slope. And the b, you might have heard it called the there you go. You might have heard called the y-intercept, but we're going to call it here as the constant. Simply because our lines might not always intersect with the y-axis. So we're going to use this idea of y equals mx plus b to solve for and write out our equations. So first things first, we're going to start with this line over here. We're going to figure out our slope. Slope, as you may recall, is rise over run. Find 2 points that you can tell the exact values of, the exact coordinates of, and simply count how many boxes up, how many boxes over. So the slope of this line comes out to be 2. So over here, to start this off, I'm going to write the number 2 next to that x, because 2 is our slope, 2 is our m. Now, I'm not going to write that plus b just yet, but over here on the side, I'm going to put y is equal to 2x plus b. So I know the slope is 2. I want to solve for b. To solve for b, we got to pick a point. Pick a point that we know is going to be on our line. So, find a point that's definitely on our line. Well, we've got a closed circle down here. So we know that the point, this one down here, of -8, comma, -3 is definitely part of this line. Well, that -8, that's an x value. That -3, that's a y value. So what I'm going to do is I'm going to take this -8, I'm going to plug it in to my x value over here. I'm going to take this -3, I'm going to plug it into the y value over here. What that's going to do is that's going to leave me with just the b value to solve for. So we've got -3 is equal to 2 times that -8 plus b. Well, that's going to be -3 is equal to -16 plus that b. Move that -16 to the other side, and we end up with 13 is equal to b. So I know my b value is 13. So back over here with this 2x, I'm going to write 2x that I have plus that 13. That's my first equation. Next up comes my domain. Piecewise functions always have a partial domain. Now I know that my domain here starts at -8 and continues on to here, continues on to -3, where I got a closed circle. So I'm going to write this out as -8, comma, -3. And put brackets on both. Then we move on to the next number, the next line. This line over here, looks like it has a slope of -2. Seems like counting our points, down 2 over 1, down 2 over 1. So right here, I'm going to put, -3, down 3, down 1, 2, 3, over 1. Yeah, these touchpads, guys. So right here, I'm going to put -3, x. I'm not going to put the plus b. Once more, I'm going to go to the side. Y is equal to -3, x plus b. I'm going to pick a point that's definitely on that line. Now I'm going to do this algebraically. Those watching, you might notice something that you can see visually. We'll talk about that at the end. I know that this definitely goes to the point of -2, 4 up here. Well, since it definitely goes through -2, 4, I'm going to take that -2 and put into that x, take that 4, put into that y. So now I got 4 is equal to -3 times that 2 plus that b. So 4 is equal to -6 plus that b. Oh, no, sorry, not -6, because it's a -2 and a -3. -2 times -3 gives us +6. There we go. Move that +6 to the other side. -2 is equal to b. So our equation here, or second line, is -3x minus 2. On the domain, we got to start where we stopped before because, look, it's a continuous function. -3 all the way to 1. Now I'm going to put a bracket on that 1, but a parentheses on that -3. That's because in the previous equation, I identified that -3 as being part of that first equation. We have a continuous function here. That means that either we'll have included here, not included there, or not included and included. When you have a continuous function like this, you'll always have one or the other. You will never have it included in both lines, and you won't have it not included in both lines. One of them must be included, one of them must be unincluded. Different class periods today went with different ones, so if your notes today look a little off, different class periods went with different assignments. Now, the thing that some of you might have noticed visually, as I mentioned before, this b, you might have learned it as the y-intercept. Well, over here, it intercepts at -2, which is what we found. So if it intercepts at the y-axis, I'm going to read that intercept. By all means, you feel free to use it. But otherwise, it's good to know how to do things algebraically. All right, third equation. Third equation, we got our last line here. This line appears to have a slope of 2. Goes over 1 up 2. So up 2 over 1. We're going to put a slope of 2. So 2x. But once more, I'm not going to put the plus b. Just off to the side, I'm going to write y equals 2x plus b. Yay, touchpads. Y equals 2x plus b, and I'm going to pick a point that's definitely on that line. It looks like this point at the end is definitely on that line. That looks like point 5, 3. Just as before, that 3 is a y value. I'm going to stick that on my y. That 5 is the next value. I'm going to stick that on my x. So now I've got 3 is equal to 2 times that 5 plus that b. So I've got 3 is equal to 10 plus b, which when we move that 10 over, b is equal to -7. So I've got 2x minus 7 as my last equation. Now I need my last domain. We're going to pick up where we left off. 1. we're going to end at 5. That 5 has to be included. But because I claimed the 1 in the previous equation up here, I'm putting parentheses on this one. With our 3 functions written, for 3 equations written out, we just add our f of x out front is equal to the funky brackets. And there's our piecewise function for problem 1. We then want to state the domain and range. So here we're essentially looking for whereabouts does our domain, as say the x values, where does it start, where does it end? Well, if we take a look, our leftmost value is at -8. Our rightmost value is at 5. So our domain here is equal to -8, 5, all included. Our range runs us from -5, our lowest y value, which is over here, all the way to our highest y value, which is up there at 7. And those are both included. We then want at what value of x does the function have an absolute maximum or an absolute minimum? Now this wants the value of x. It's a little different from some of the other problems we've had. Wants the value of x, so our max will be at x is equal to -3. Because -3 is the x coordinate right below our maximum. Our min is at x equals -1 because, +1, because even though our minimum is down here, we want the x value at 1. So that is how we do the entirety of problem 1. We're going to have a similar thing for problem 2. Except in problem 2, we now have 4 different equations we're going to write. 4, because we've got this linear function here, we've got a parabola, but then that parabola ends in an open circle. Next line begins with that open circle. So 1, 2, 3, 4. We have to account for that point. So let's take a look at things. And I might not have the space to put it here, put it off to the side. First things first, we're going to start off just like we did before with our linear function. Linear function here, looks like the slope there is 2/3. So 2/3 x. Again, not putting the plus b. It's a linear function, so over here, y is equal to 2/3 of x plus b. Now we're going to pick a point. I'm going to pick the point -3, 0. And just like before, that -3 goes into that x, that 0 goes into the y. Anytime you can work with a 0, you should work with that 0. So we have 0 is equal to -2 plus b, which means that b is equal to 2. So 2/3 x plus 2. On the domain, well, we've got an arrow at the end of this. So on the domain of -infinity, I'm sorry I'm sliding a little bit, -infinity all the way to -3. And I'm going to choose not to include in this domain. Yes, I did use it for this point. To solve for b, that is perfectly okay. You can use points that are not included as long as it touches that line. Then we have our parabola. As you may recall from Algebra 2, but I know for some of y'all, Algebra 2 might have been a year and a half, 2 years ago. there's what's known as the vertex form. Vertex form of y is equal to a times parentheses x minus h squared plus k, where h and k make up the vertex. As long as we know the vertex, we can use this form. We know our vertex here is at 0, 9. Let's go ahead and plug those values in. Y is equal to a times x minus 0 squared plus k, plus 9. Now we need to solve for our a value. We solve for a value just like we did before by picking another point on the line. I'm going to pick this value again. It's including both lines, so I can pick it both times. I'm going to pick that -3, 0. That 0 replaces my y. So 0 is equal to a times x minus, but x is being replaced by -3 minus that 0 squared plus that 9. So now we solve things out. 0 is equal to a times -3 squared, because -3 minus 0 is -3 plus 9. -3 squared is 9, so 0 is equal to 9a plus 9. Move that 9 over. -9 is equal to 9a, which means that a is equal -1. That makes sense because if you look at our parabola, it opens downwards. Downwards parabolas always have a negative coefficient. I stick that a equals -1 back into my equation. I write it out. So now I've got our negative x minus 0 squared plus 9. There is a way to simplify that if you want to. If you don't want to, don't worry about it. We need our domain. -3 is where we're going to start. Looks like it ends at 2. Now, 2 is definitely not included, but that -3 has to be included. Then we come to the point. That thing right there. That is part of our piecewise function. Specifically, that is the point 2, -3. This is how it gets written. -3 goes over here with the equations. And where is it equal to -3? Well, it's equal to -3 at x equals 2, but only at x equals 2. And that's it. That's how we show that little point there. Then move on to our last one. We got our line. The slope there is negative. Slope there looks like it's -2. So right over here, -2x. And then over here, I've got my y is equal to -2x plus b. So now, pick a point. Point that we definitely go through. Most classes have preferred to use the point 4, 1, because 4, 1 is definitely on there. Plug in our values. 1 for that y is equal to -2 times that 4 plus that b. So 1 is equal to -8 plus b. Add 8 to both sides. 9 is equal to b. So -2x plus 9. Lots of 9s here. And that's going to start at 2, but not include 2, and keep on going. It looks like to infinity. Because yes, this arrow here is pointing down, but our domain cares about left and right. So it's also pointing to the right. With our 4 things written out, put our big old brackets there, and that's our f of x. State the domain and range. Our domain is going to be all real numbers. Our range is going to be negative infinity to 9, including that 9, not including that infinity. At what values of x does the function have the absolute maximum? That occurs at x is equal to 0. Now there was a third problem for this. That's going to be a separate video. I encourage you to work that third problem on your own before watching that video. But as always, folks, please let me know if you have any questions about anything relating to mathematics.